Hi, today we're going to start out looking at a sorting activity. In this activity, you're going to be given some graphs, some relations, some ordered pairs, some tables, and you're to identify the domain and range of each one. Well, in A, I've already identified what the domain and the range would be for this mapping diagram. Remember, when I write domain, I use a capital D, and in the fancy brackets, I write the independent variable. In this case, it's the mapping, so it would be the letters that are on the left-hand side. The range would be what's on the right-hand side. Then we go down to B. On B down here, I have this horizontal line graphed. Now when I identify the domain are my x's. You have to ask yourself, what can x be? Well, if this is a horizontal line made up of a bunch of points on this line, x can be any number, so we say that it's all real numbers. Now my range are my y's, so you have to ask yourself, well, what are the y values on this graph? Well, if you take a look at the points along here, it doesn't go past this y value right here. That y value would be 2, so my range here would just be that my range is 2. And 2 only. If I take a look at C, I have a graphed line right here. This graphed line has a bunch of points on it. All those points are made up of different x values. When I do my domain, I'm asking myself for my x's. What can x be on this line? X can be any number, so we say it's all real numbers. My range? Well, what are the corresponding y values on those points? Well, again, they can be any value, so I'm going to put all real numbers. Whenever we have a diagonal line that's graphed, the domain and range will always both be all real numbers. In letter D, I have a relation. My domain would be all of the x values, so I've got 2, 3, 4. My range would be all my y values, but when I look at my range, they are all 3's. So when I write my range, remember we only write that number once. In E, I have a table. My domain would have to be all my x values. But remember, when we write the domain, just like the range, if a number repeats, we only write it once. And we want those numbers in numerical order. So 1, 3, 5. But the 1 repeated at the end, so I do not have to write that. My range are all my y values. 2, 4, 6, and 8. Okay? Now what I want you to do in the bottom left-hand corner is we want to identify which ones are functions and which ones are not. Well, the way we tell, remember, is by the domain. As long as the domain does not repeat. For instance, in A, did any of these arrows right here repeat? Did you have more than one coming off of any of those letters? No, we did not. So that's a function, so we're going to put A down here. B, did any of those x values repeat? If I was to do the vertical line test, it's only going to hit it at one spot, so B is a function. What about C? Does it pass the vertical line test? Yep, it's only going to hit any of those vertical lines only once, so that's a function. What about D? Did my x coordinates repeat? Nope, they did not, so that is a function. In E, did any of my x values repeat? Oh, yep, right down here it did, so E is the only one that is not a function. Here are some more examples for that sorting activity. Please stop the video, identify the domain and range of each one, and identify which are functions and which are not functions, and then check your work. Okay, check your domains and range with the answers that I have given below. Now remember that when I write all real numbers, I can use the math symbol that looks like a double bar R. I did type out all real numbers, but a double bar R means the same thing as all real numbers. One thing I want to point out in these examples would be something like I and J. I is like a sideways U. You see how it doesn't go past that x value, that is why I had to say x is greater than or equal to -2. All the x values, all the points that make up that curve, all the x values either -2 or greater than -2. In J down here, you notice that we don't use any points below there. So what's that lowest y value is a 1. So that's why the range is y is greater than or equal to 1. The x can be all real numbers here because this u keeps going and will eventually slowly open up, and it could use all of those x values. Now, did you identify which ones were functions and which ones were not functions? The functions were the ones where the x's do not repeat. So we have f. G is a vertical line. Well, you've got points on top of each other there, so G is not a function. H, did any of my x's repeat? No, so H is a function. I, well, if I put a vertical line on here, the vertical line test, it does not pass it because it goes through that vertical line more than once, so that is not a function. And J, is that a function? That is a function because if the domain is all real numbers, it can be any number and they're not going to repeat, so J is also a function. Let's take a look. Oops. Okay, my little oops is I was pulled up the wrong thing. Okay, let's take a look now at this one. It says find the range of each function for their domain. So they're giving me specific numbers to use for x. What we're going to do here is we're going to create a table. We're going to do like a t-chart here. You're going to put those x values in, and then you're going to substitute them in one at a time for 6x plus 1. You're going to evaluate this function. So we have 6 times -2 plus 1, which would give me -12 plus 1, which is -11. I have 6 times 0 plus 1, which is 0 plus 1, which is 1. I have 6 times 0.5 plus 1. Well, a half of 6 is 3. 3 plus 1 is 4. Remember, when we evaluate, we follow the order of operations. Multiplication comes before addition. That's why I do this multiplication, then that addition. So instead of find the range, I can say my range is, and I can do -11, 1, and 4 for my answer. Okay, let's take a look at the next one. I'm going to ask you to do the same kind of thing on this next one. But now I've got some absolute value bars here. Okay, I'm still going to do a table because the directions are the same. You want me to find the range, given the domain is -2, 0, and 0.5. I'm doing the absolute value of x minus 5. Now remember, on an absolute value, everything comes out positive. Doesn't matter what's inside, everything always comes out positive. So when I have the absolute value of -2 minus 5, the absolute value of -2 is 2, and I still have the -5 in the back. 2 minus 5 gives me -3. When I put 0 inside those absolute value bars, well, the absolute value of 0 is 0, minus 5, and I get -5. I put 0.5 in place of the x for the absolute value. The absolute value of 0.5 is 0.5, minus 5 gives me a -4.5. So my range for this one would be my -3, -5, -4.5. And when I write my range, I would like to put that in numerical order. Oops. Let me just take that out and put the -4.5 and the -3. And I've got one more for you that's like this. The equation just looks a little bit different. It has a cube on it. Now when we're doing this one, and it says find the range, that means we're going to do a table. And in that table, we're going to do that -2, that 0, and that 0.5. So if I put the t cubed minus 1 up there, that means that cube has to come before the -1. Now I'm taking the -2. And if 2 has a negative on it, I'm going to put parentheses around it, then put the 3 on for the exponent. And I'm going to remember I do negative 2 cubed. Negative 2 cubed means negative 2 times negative 2 times negative 2. I'm going to multiply it out 3 times. So I'm going to get negative 8 minus 1, which is negative 9. I put the 0 in there. And I have to cube it, then subtract 1. Well, 0 cubed, 0 times 0 times 0 is 0, minus 1 is negative 1. Then I want to take and I want to put that 0.5 in there. So I have to cube that. 0.5 cubed, 0.5 times 0.5 times 0.5 is 0.125, and I want a minus 1. So I'll get a negative 0.875. So my range here would be negative 9, negative 1, and negative 0.875.